I said something offhanded in response to Joe Rogan a couple weeks back. Was that a couple weeks? Boy, it doesn't feel like it. But I think it must have been...
Week and a half?
Yeah, a week and a half, something like that. Anyway, he asked me a question. I've now forgotten what it was about antibodies. And I said to him, look, I think the concept of antibodies has loomed way too large in the public conversation over immunity in the context of COVID. And my guess is that the reason we have focused on antibodies is because the public knows what an antibody is. Yes, agreed, kind of loosely. But the point is, when you say antibody, it immediately conjures something, right? Whereas, if you talked about almost any other concept, if I say clonal selection, right, which is a fundamental concept in immunology, almost nobody knows what you're talking about. So I do think that this is... It's almost a tell that suggests that what we are faced with is propaganda.
So I haven't listened to that part of the clip, and I may stop me if this just isn't making no sense at all. But so your argument is that maybe part of the reason that we're talking about antibodies so much is simply because the public already knows what they are, and so is sort of ready to receive this sort of talk. But it feels to me like it's also true. And I haven't gone back and reviewed this at all, so I may be wrong here. But it's also true that antibodies are easier to find in the body, like they're easier to test for than, say, T cells. And so we have clinical tests that find the thing that's easy to measure. And that people already know about. So I mean, it feels like it could be both, unless I'm wrong. But I
no,
think
you're not,
this is right. Right?
You're not wrong. It's an easy assay.
It's PCR, and it's the wrong thing to be doing, right? For a number of reasons. But those two reasons, which have nothing to do with whether or not they're the right thing, make it the easy and publicly amenable thing to be talking about.
Yeah, I get it, right? It's something that we can talk about because we're more likely to have information about it because it's easier to come by that information. It's less arduous. I don't think that's really driving this at all. In fact, we can see even in the recent testing that was used, I think it was for the EUA for the childhood so-called vaccines, where they had measured antibodies and claimed that implied that these were very good at creating immunity to modern variants. And the point is, there was a giant leap in there, right? Which is, it's not clear. First of all, antibodies aren't what people think, right? You're peering into a complex system and you are able to identify something, and that is resulting in you saying, oh, there are a whole bunch of antibodies, and it doesn't inherently mean anything. In fact, antibodies can be negative. They can make the disease more capable of getting into your cells. So anyway, I do feel like it is indicative of the propagandistic nature of our discussion, that we are being presented with something that can then, emerge into the conversation where people are then talking to each other about antibodies because they know a little something about antibodies. Whereas if you were talking about receptors on a T cell, they'd be scratching their heads. Well, what's a receptor? What is a T cell? Why would a receptor be useful in this battle? So anyway, there is something weird about the focus on antibodies. And so anyway, I off the cuff said to Joe that I think it's about the fact that the public knows what they are rather than the fact that that's where the conversation should be centered. And then a friend of ours, Jumi Kim, pursued this question. I did ask her, and she was at least somewhat inspired to look into it because of my comment to Joe. But anyway, what she came up with is very interesting, and I'll just sort of loosely say what it is. I would suggest everybody check out, hey, Zach, can you show Jumi's Substack post? So I would suggest people check out her Substack. She has done a bunch of these deep dives, and she's very good at doing this in plain English so that it's very accessible. She's highly capable as a biologist, so the technical matter is all right. She's not cheating on the technical stuff, but she presents it in a way you can understand. why she reaches the conclusion she does. She presents with the references. So anyway, it's really good stuff.
Yeah, and for those just listening, her Substack is called Let's Be Clear. It's really quite excellent.
It really is quite excellent. So anyway, what she discusses in here is all of the little threads of evidence that suggest that at the very least, antibodies are not the end-all and be-all of immunity to COVID. And she goes through some evidence that I was frankly unaware of. Now that I've seen her explore it, yeah, I should have wondered if the evidence existed in this form. But of people who can't produce antibodies for one of a number of reasons, either because they're on a drug that is suppressing their production of antibodies, or they have a congenital defect that causes them not to be producing antibodies. And as she correctly points out, the fact that these people are not doomed by COVID means they are successfully fending it off, which implies a whole other system that is not captured in the, oh my God, it creates a great titer of antibodies. So anyway, those who are more deeply knowledgeable about immunology will spot at least one of the other components of that system, which is that we basically have two kinds of circulating cells that manage this very specific kind of immunity, right? That is an adaptive immunity that learns to fend off a pathogen, right? We have B cells. B cells have receptors on them, and they produce free-floating antibodies. And those two things have a relationship. So when a receptor is triggered by an antigen, then the release of antibodies occurs in at least many cases, whereas a T cell produces no free-floating antibodies. It has receptors, it gets triggered, and they create lots of other phenomena. They can, for example, people will remember our discussion from, I think, last week, and many other times, where we discussed the question of what happens when your own cell is producing not only your own antigens, but is producing foreign antigens. Well, that cell gets destroyed. The body destroys it, and it destroys it using T cells. These T cells identify this compromised cell. They, in any natural case that I know of, a cell that is producing foreign antigens and self-antigens is an infected cell, and so killing it is the way to get rid of it, right? It's bad to kill your own cells, but it's better to do that than leave them in place. So anyway, you've got these two different systems. And so the fact that the B cell antibody-based immunity is not the sum total of COVID immunity clearly is evidenced by
it is never, right? For any illness, for any pathogen response, is it ever entirely B cell antibody based?
There will be things that are primarily B cell. So, for example,
and what are the conditions that predict that?
Good question. This is off the top of my head, having studied this many, many years ago, and as an undergraduate in a medical school class. But nonetheless, it's been a long time, and the field has grown, and
Sure.
I've learned a lot during COVID that I didn't learn back then. But for example, if you had a bacterium, right, there's some bacteria that you might fend off by just gumming them up with antibodies that would then cause them to be consumed by macrophages, right? That might be the go-to mechanism. And because the bacterium is not getting into your cells, T cells might be none of the response or not primary. So, I hesitate to say anything in absolute terms in biology, because as my advisor and member of your committee, Dick Alexander, would always say, he's like, that's the quickest route to be wrong.
Yep.
Because biology, he used to make this point about insects, that anything you think never happens in animals, check out insects. You'll find it's there somewhere.
Yeah. Well, it seems like one trend that for which there will be exceptions will be that single acute exposure to something might be, your body might launch a successful immune response entirely or almost entirely with B cells and eradicate it. And if you're not exposed to it again, it's gone.
Right. Now, this is actually covers one of the things. So my purpose today is to actually just get people used to hearing about this, because I have a feeling where the conversation is about to go is, hey, is this antibody stuff really what we've been led to believe, or is it being used to mesmerize us when there's a larger conversation that might say something very different, right? Mm-hmm. And so one thing that is the case, right? People have I'm now understanding, people have a misunderstanding in their mind about antibodies being the result of either natural immunity developed in response to infection or vaccination.
Acquired immunity from a vaccination, for
right.
instance.
And what this misses is that, in fact, and forgive me if you've heard this before, but there is a system that has a rudimentary set of cells that are not highly effective at attacking any pathogen they haven't seen, but have a basic ability to attack anything that isn't self, right? And so the point is, it is wrong if what you've got in your mind is, oh, I need something to create antibodies, and I'm not going to have that until I've been infected with the pathogen, or I've gotten a vaccine, let's say a classic vaccine that does this well. That's not really right. What happens if you get infected with a pathogen that you have never seen before is a process of evolution is triggered inside your immune system. And what literally happens, and I believe it is the most interesting biological fact I am aware of, but what happens is your cells, be they B or T cells, or both, literally evolve. They evolve on the time scale that pathogens evolve. And they do so, what they do is they take that crude ability to electromagnetically attach, right, or to be triggered in the case of a receptor. They take that crude ability and they refine it. And the way they do this is through something called clonal selection, where that tiny subset of your immune cells that is triggered by some pathogen you've never seen, right, it induces the cells that produce either that antibody or has those receptors on its surface to diversify, to produce daughter cells that are not alike. They are actually programmed to be not alike. And then that fraction of the daughter cells that is best triggered then produces its own daughter cells. So you get this rapid pattern of evolution, right?
It's a confusing language, but it's called clonal selection.
Well, if you know...
If the daughter cells are different, and you have in your head what most people have in their head about what a clone means. It's confusing language.
Well, it's actually a little bit like our many earlier discussions about why chromosomes are not the end-all and be-all of sex determination, even in humans where sex is determined through chromosomes, right? Mm-hmm. And the point is, we notice the pattern, that there is a chromosomal pattern, that men tend to be XY, women tend to be XX, and so strongly so that we tend to want to synonymize them. But as you point out, the thing that really is not a broken pattern is that there are two...
It's far more ancient than genetic sex determination.
Right, is the gamete size, which actually dictates what is male and what's female. So the shortcut of saying, oh, it's the chromosomes gets you in trouble. And in the same way here, the idea that clone means identical, right, is not right. What's actually happening is you've got an asexual process that has a random number generator triggered in it in order to get diversity. It's a cheat to bypass sex as a mechanism for producing diversity, right? So it really is clonal, and it really is selection. Mm-hmm. In fact, Peter Medawar was one of the pioneers here. Peter Medawar, who I believe got the Nobel Prize, he's a British biologist, got the Nobel Prize for discovering the basis of graft rejection, right? Graft rejection being the result of the fact that if you take a organ from somebody who has your blood type, so there's no big antigen incompatibility, and you transplant it into you, well, it still isn't self, right? They've spelled all of the proteins differently, and so your immune system will attack it, right? And so getting a match, a molecular electromagnetic match for you is important, which is why it's so hard to find a donor, right? Somebody has to die who has that match before you get an organ that you're not going to reject. But in any case, okay, so you've got these cells that are capable of evolving to get better. But what that means is that you have the rudimentary cells, the library, the crude library of, it's not the super refined tool that fits the thing just so. It's the adjustable crescent wrench that fits it, kinda, right? It's that kind of thing. But that isn't nothing. In fact, it's keeping you alive, right? That thing, which is always surveilling, for looking for hostile pathogens to get the place to start the process of evolving a good response, is ever present, right? And so anyway, the antibodies and that response is always available. It's just not high quality. And the thing that vaccines do, and now I'm talking about good vaccines in which nobody would argue that they're anything other than vaccines, what those things do is they provide an advanced warning. Right, they provide a description of the hostile entity in advance, so that process of learning the molecular signal, the electromagnetic signal of those antigens, can be done when you're not sick, right, or minimally sick in the case of a attenuated virus vaccine, right? So you do that work when you're not challenged by the thing, and then you run into the thing. It's like, oh, I already know how to beat that. And in fact, I'm going to beat it so quick.
I've got a head start. My immune system has a head start on you because I haven't seen you before, but I've seen something like you enough that I'm ready.
Right. And so presumably we are constantly being invaded by viruses and other pathogens for which we already have the formula, and we never get any symptoms because we beat them so quickly, right? And so that's how it's supposed to work. But don't get the idea that you don't have the immunity until something, either the infection or a vaccine, gives it to you. That's just not right. Inside of this discussion about antibodies, we have now started discussing different classes of antibodies, right? We discussed IgG, which is the primary antibody thought to be responsible, at least in the case of SARS-CoV-2 and probably most viruses, for neutralizing these things. But that is what is induced by the early inoculations. The problem is, and many people have now raised this in different ways, that this is not ideally the kind of immunity that you want to stop transmission of this thing. And it may be that at some level, the very design of this vaccination was doomed from the start not to stop transmission because it's in the wrong place, right? Your lymph can be full of immune cells that are well alerted to this pathogen, but if your mucosa aren't brimming over with antibodies that identify the pathogen as soon as it lands, it can still get into your lungs. And so the way to think about this, the way to listen for it, is that the antibodies, the class of antibodies that are responsible for mucosal immunity is IgA, not IgG, right? So anyway, and you may also have heard of IgE, which is the one that paradoxically seems to produce nothing but trouble, right? It produces allergies, right? Places where you have an immune reaction to stuff that is not a pathogen. And that's not good. You can, in fact, be killed by your own immune response to something that is not a pathogen, like a bee sting. You'll be overwhelmed with your own inflammation.
I wonder if it might not have been in an earlier era when we weren't able to travel with such magical alacrity, a measure of localness. If you are now being exposed to something at 10 or 20 or 30 especially, or 40, that you've never been exposed to before, maybe you have strayed into territory where other things are going to be new as well.
Interesting. If you would take it as some kind of a proxy for something. Interesting. I hadn't thought anything like that. Quite possible.
It's an aside.
Yep. But yeah, actually, it sort of fits with the discussion of the repulsion that the physical revulsion that is sometimes felt about foreign stuff. And
I thought you were going to talk about sickness. Oh.
Well, but that, let's put it this way. Amongst racists, the belief that the other is not only, an economic threat or a military threat, but dirty, disgusting. Right. So anyway, who knows? Maybe there is some history that would explain that, and it's not just a trick, a propagandistic trick.
Yeah. Just an aside that I know you're still talking about IgA and G here, but one of the places where that script gets very much flipped is in the European arrival on the eastern coast of North America, where both Europeans and Native Americans who they interacted with perceived that the Native Americans were very clean and the Europeans were filthy, and what the hell's wrong with those people anyway? The Europeans, like what is wrong with those Europeans? How can they live like that?
Right. No, it is true. And then, of course, at the point that the Europeans were landing in North America, the game was already in some sense over as a result of the pathogen that had spread due to early contact. But, clearly at some level, the Europeans were a pathological threat that they didn't even presumably understand.
Yeah, right.
Which is a fascinating and very, very tragic story.
Back to immunoglobulin.
Yeah, back to immunoglobulin. So immunoglobulin is just a synonym for antibody.
And it's what the IG stands for. IgG, IgA, IgE.
Right. And you should know, so this would be better done with visuals, although most of our followers are just listening anyway. But the fact is, these antibodies, which you have seen diagrammed a million times as little Y-shaped proteins, where the tips of the Y are the thing that sticks to the antigen, and then the tail is what dictates what class, IgA, IgE, IgG, etc., the antibody is in. But that thing has a close evolutionary relationship to the receptors that sit on the surface of the B cells. So you can imagine if a B cell is producing antibodies and those antibodies find their target and they land, that doesn't tell the B cell that produced them anything special. They're not, in contact. So there have to be receptors on the cell itself so that the cell itself knows, wait, it's my time. It's like the bank guard who, spends an entire career sitting in the bank where nothing happens. And then finally the robber shows up and it's like, that's what I've been training for, right? So anyway, the receptors on the T cells and the B cells have an evolutionary relationship. They're not independent, right? These are two versions, they're variations, the evolutionary variations on a theme. And the receptors and the antibodies have a relationship. And anyway, therein lies the story. But that's probably almost enough to cap this off for today. Purpose being really just to get people used to the conversation, since I think we're about to end up talking about whether this campaign made any sense in the first place.
This campaign meaning this kind of treatment that was sold to us as a vaccine?
Yes.
What campaign?
The vaccination campaign, right? Creating IgG immunity in your lymph and blood. Was that ever? Did anybody think that was going to arrest the progress of this pathogen? And if so, by what mechanism, right? An IgA response in the mucosa might have blocked transmission. And there's a way to induce that, which is to produce the pseudo-infection or the attenuated infection in the mucosa, where the mucosa learns this lesson instead of your lymph.
Which is to say, a different drug and delivered differently.
Right.
A nasal vaccine of a traditional sort.
Right. And I will say, yes, we will be accused of conspiratorial thinking. On the other hand, we've seen an awful lot of collusion just to obscure the truth. So I don't know why we would draw a line. But there is an aspect in which there are several different lines of evidence that, pharma was very excited about this platform. And it's easy to see why, because once this platform is something that people accept, then producing
the R&D is just slashed. Like, it takes no time at all, which was one of the selling points, right? Like, wow, we are so lucky that we got this so fast, and you have a chance to replace literally years of R&D, and then I don't know how it is that they are going to continue to justify clinical trials being abbreviated like they did. But, years into less than a year is going to be quite a remarkable cost savings.
Well, if the vaccines had been less destructive than they turned out to be, or if they had been better at controlling the story so that people thought they were less destructive, then the answer is, oh, well, this new platform requires a whole new regulatory structure, because why would you spend decades when the only thing you're swapping out is a sequence, right? Yeah. So you can see their argument, right? You can see them, frothing at the mouth, frankly, at the profits that they're going to generate by translating every vaccine into this new platform and just, shooting you up. So it didn't work out that way. And hopefully people are awake enough, or enough people are awake enough that, I'll say two brief things here. One, to understand that as fantastic as the potential of inducing the production of proteins using transfection with mRNA, as much as that has tremendous potential, we don't know that it can be done usefully, and there's a basic safety problem that is going to accompany every single attempt. And the basic safety problem is you're going to make the patient's cells produce foreign antigen, and that is going to get them targeted by the patient's immune system. And unless you have some really sophisticated way of keeping that damage to some tissue where you can afford it, it's game over, right? It's not worth it. And so, anyway, to my way of thinking, that's where the conversation has to be. Have you solved that problem? If so, tell us how you've solved that problem, and we'll talk about whether or not what you're saying makes any sense, or if it sounds like PR, right? But until you solve that problem, well, you've just seen a totally predictable disaster, and we're not doing that again. So hopefully, so anyway, it's that question written over all sorts of vaccines that that they basically want to change the process on.